Hello Legacy students, Marsh here. So today we're going to look at trapezoids and kites, the last two quadrilaterals of this chapter. You're going to want to have your foldable out, your notebook for the kites notes, because notice kites is not on the foldable. And then a calculator, and then some highlighting, some color pencils just to draw on the diagrams again. What we're going to look at is the trapezoids foldable, the trapezoids part, and then we're also going to talk as well through kites, which is not on there. Alright, so let's talk about what does it mean to be a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So if I have a trapezoid, all I have is a single pair of parallel sides. Now, they are not congruent, they are just parallel. Same with these two sides, they are not parallel nor are they congruent. One thing about them, though, you can find what's known as the median of a trapezoid. Basically, it's the, if you want to consider it the base in the middle of the two bases, because this is a base up here, this is called the base down here. Normally, you'll hear the other sides referred to as legs. So, my median is the guy in the middle. To find him, what you do is you add up the two bases and you multiply by a half. Also, if you want to write it this way, there's another way to see this formula. Add the two bases and divide by 2, if that multiplying by a half kind of freaks you out a little. Now, there is also a special kind of trapezoid who's called an isosceles trapezoid. What he is a trapezoid whose legs are congruent. Same thing, he still has only one side of parallel sides. That is right here and right here. The median is still the 1/2 times the base 1 plus base 2, or base 1 plus base 2 divided by 2. The legs are congruent, which means this side is congruent to this side. Also in an isosceles trapezoid, our diagonals are congruent. So this diagonal right here is congruent to this diagonal right here. With that as well, our base angles are congruent, which tells me that right here, this base angle is congruent to this base angle, and on the other side of that coin up here is also congruent to that angle as well. So keep that in mind when we're solving some trapezoid problems here. So I have example 1 here. I need to find the value of x. Now here is the thing, this is still a parallel sides, right? These two sides are parallel, which tells me that these two add up, are supplementary. They are adding up to 180. So I know 12x plus 3 plus 13x plus 2 has to equal 180 degrees. So I know that 25x, because 12x and 13x makes 12x, plus 5 has to equal 180. So I subtract 5 here. I get 25x equals 175. Looks like I gotta divide by 25. So I get x is 7 for an answer for that one. Example 2. I know AB is 7y plus 6. EF is 5y minus 3, and DC is y minus 2. Find the value of y. Ooh, that's kind of gross. Well, I know that these two, the outside bases, divided by 2 or multiplied by a half equals EF. So let's actually write that out. 1/2 of my two bases added together equals the median. Now, let's figure out what's the inside here. 1/2, I'll get 8y plus 4, right? Because y plus 7y, that's 8y. -2 plus 6 is 4. That's equal to 5y minus 3. Let's distribute that 1/2 in. So I would get 4y plus 2 equals 5y minus 3. Let's solve for y now. So I'm going to subtract 4y from both sides. And then I can add 3 as well. 4y minus 4y, that's gone. 2 plus 3 is 5. 5y minus 4y, that's just y, and that's gone too. So it looks like y is in fact equal to 5. Let's try a couple of examples of isosceles trapezoids. So, done is an isosceles trapezoid. The measure of angle EDO, this one right here, is 110 degrees, and the measure of DEN is 15x minus 5. Please find the value of x. Well, same thing. This is still parallel sides, right? Here's my transversal, so I know that these two angles together have to make 180. So 110 plus 15x minus 5 does equal 180. Well, 110 minus 5, that's 105. Looks like I need to subtract 105. So I get 15x equals 75, because that's 180 minus 105. Divided by 15. So x equals 5, it looks like, for an answer. Let's try example 4 now. I am told trap is an isosceles trapezoid if PR is 3x minus 7 and TA equals 20. I need to find the value of x. Well, what do we know about isosceles trapezoids? Let's look at our properties here. We're talking diagonals. Oh, diagonals are congruent. So that would tell me that 3x minus 7 equals 20. So let's go ahead and solve for x. Gotta add 7. 20 plus 7, that's 27. Divide by 3, so I get x equals 9, it looks like, for an answer. Now, in your notebook, you're going to need to take down some notes because kites are not in your quadrilaterals foldable. What, in fact, is a kite? You've seen them before because you've kind of flown what's known as a kite in the sky. Kites are a quadrilateral that has two pairs of consecutive congruent sides. Now, here is the thing about kites. First thing, angles. One pair of opposite angles are congruent, which means this angle right here, angle A, is congruent to angle C. Now notice, guys, B is not congruent to D. That's something to keep in mind while we're working. For sides, you have two disjoint pairs of consecutive sides are congruent. What do I mean by that? That tells me AB is congruent to BC and AD is congruent to CD. So notice upper little triangles are congruent, the diagonals are congruent, and then these guys are congruent as well. What do we know? Diagonals are perpendicular, so that tells me that I have right angles in here. These are all have to be a right angle. Short diagonal is bisected, so this piece right here, if I take my highlighter here, this piece right here, he is bisected, which tells me that this side A to this middle point is the same as C to that middle point. And then non-congruent angles are bisected, which tells me that this angle and this angle are congruent to one another. And then same thing down here. Those guys are congruent as, or are bisected as well. Let's take a look at some examples of kites. You're going to want to write these in your notebook as well. So in here, well, I'm missing two angles, right? 1 and 2. Well, based on my properties of kites, I know that these two, angle 1 and angle 2, have to be the same, right? Because they are congruent angles. and I know there's 360 degrees inside of a quadrilateral. So I know 101 plus 48 plus x plus another x has to equal 360. Well, let's combine some like terms here. So this would be 149, this would be 2x, and that equals 360. Let's subtract 149 from both sides. We get 2x equals 211. Whoops, add an extra 1 there. Looks like we got to divide by 2. So we got 105.5 for x. That would be for both angle 1 and, in fact, angle 2. Middle one here. Draw a line here. What can I do here? Well, it is a kite. Consecutive sides. Well, that must tell me that this side and this side are the same, and this side and this side are the same. So let's just pair these two together. So 4x plus 1 has to equal 17. Subtract 1, so I get 4x equals 16. Looks like I got to divide by 4. X equals 4. Now here's the cool thing. If I would have paired these two, I would have gotten x equals 4 as well. Now let's look at this last one. We've got a lot of angles kind of hanging out on this last one. Well, one thing I do notice. Okay, so I have this kind of this smaller triangle right here, right? If I kind of make that and blow it up here, I got 2x here, 10x minus 6. And remember, diagonal's perpendicular. So I have a right angle right here. I can actually find x because I have a triangle, and triangles have 180 degrees in them. So I know that 2x plus 90 plus 10x minus 6 has to equal 180 degrees. If I add stuff together, I'll get 12x plus 84 equals 180. Let's subtract 84 from both sides. So I'll get 12x equals 96. Divide by 12. So I get x equals 8 for an answer. And that's the end of this video. See you later, Sabers.